Okay, we're in section 28 of the notes. It's polar coordinates. This material was covered in math, most of the material. There's some calculus here, of course, here, but this material was covered in math 120 at Essex County College. Now, again, if you took pre-calculus at a different school at a prior time, it's really the same material. All right. So I'm just going to sort of review some stuff. And to do that, I'm going to use polar graph paper. So I'm going to take this section here. I'm going to copy it. I'm going to bring it to the next page. And this is what's called polar graph paper. All right. So I'll explain the use of this. This paper can be printed out if you want to use it. I think you can also purchase it on Amazon if you want as a pre-printed, if you like. It's up to you. But it's important to have access to this to understand or to review what you've done in math 120. All right. So what I want to do is I'm going to talk about one point at a time. But before I do that, I want to, indicate that looking at this paper over here, it's on top. This paper here, I should say this image here, sits on top of the XY axis. So this is the abscissa, the x-axis, and this is the ordinate or the y-axis. All right. So I'm seeing that. And what I'm seeing over here, I'm seeing they got degrees down for me. And it's rotational. What we're talking about is standard position. We got an origin over here. This is called a pole now. So that red dot's a pole. And if we're looking at this over here, when we rotate, we're rotating counterclockwise. That means a positive angle through these measures over here. Round and around it goes, okay? So, someone says, could you rotate the other direction? Well, that means it's a negative angle. The other thing I want to point out to you is that there's rays coming from this origin over here, and they're moving out like this, all right? This is what's known as a distance from the origin, and it's a directed distance. So for example, a positive number would go in the direction of the angle that's given. If it's a negative number, it would go in the opposite direction. Now, what's nice about having a graph paper like this, it's pretty easy to see this is 30. The opposite would be 210. The opposite of 90 would be 270. The opposite of 330, let's trace over, would be 150. All right. All stuff that you've should be familiar with, whether you're familiar with or can remember polar coordinates or not. Then the question comes is, what do they want you to do with this? Well, a couple of things. The first thing they want you to do is just understand that they're going to be reporting a point to you as an ordered pair of numbers. The ordered pair of numbers is going to be R. R is called a directed distance. That directed distance is no longer just a radius, but it could be of a circle. Which I think I want to point over here. You see a bunch of circles drawn here. And what are these circles over here? For example, this circle over here, that radius 1, radius 2, radius 3, radius 4, radius 5, radius 6, radius 7. All right. So someone could say, could you go further out? Of course you could. Are these numbers sacred? No, you could change that to 10, 20, 30, 40, 50, 60, 70. All right. You could also change these numbers over here to the radian measure, which is really what we should be sticking with. I think most people are more comfortable using the degree measure though. So if I see a radian, I'll talk about its degree measure. So the first thing I want to do is be able to plot. And I want to tell you what I'm going to plot. I'm going to plot points. And the first point I want to plot is 1 comma pi over 3. All right, so the first thing I want to get across to you is that pi over 3 is an angle. Again, these are given as r theta. What's the angle going to be? Well, if you need to, do this over here. And that would be 60 degrees. So what you need to do is locate 60 degrees over here. Let me point out what I mean by that. That's 60 degrees. Now, what do they want you to do? They want you to go in the direction 1 unit towards that angle. So if I did that, what would the point be? Let me blow this up a little tiny bit for you. The point would be right here. That's 1 unit away from the origin in the direction of 60 degrees. All right, let's keep going. And we just did that one. Let's do another one. And I'll put that one down for you. The other one I want to do is and again, I'm just looking at the notes, by the way. So all I'm doing, I want to do 2 minus pi over 6. All right, I'm going to convert the angle. That's going to be minus 30 degrees. All right, so let's go back over here. And what I want to do is I want to find out where minus 30 degrees is. So I'm looking at this thing over here and I realize that I'm rotating in a clockwise direction 30 degrees. So this line here, this line right here is minus 30 degrees. Now, what do they want me to do? They want me to go 2 units in the direction of that ray. And where's that going to be? Right over here. Okay, I'll put that down for you. All right, that point's done. All right, so what we're doing is graphing points. All right, let's keep going. What's next one going to be? Well, let's write it down. It's going to be, whoops, -2 minus pi over 2. Well, it's -2. I'm going to put down, I'll be a little better at this. This is minus 90 degrees. All right. So then the question comes, again, I'm doing this point over here. I have to find out where minus 90 degrees is. So if I were to do that, that's right over here. It's actually coterminal with 270. Now, what does it say to do? It says go in the directed distance, not towards the 270, but it says it's a negative number. So it's away from the 270. How many units? 2 units. So what am I doing? I'm looking for the circle of radius 2, and that's right over here. Let me sure I'm doing that right. All right, that's done. All right, let's keep looking through this. And, I'm just doing one point at a time. I want to do this one over here. And again, don't be intimidated. And let's put that one over here. So that's going to be -2, I'm sorry, -3, minus pi over 3. What do you get over here? -3. And that's going to be minus, I'm going to put in a degree measure. That's going to be minus 60 degrees, right? So what I have to do, I have to find where minus 60 degrees is. Let me show you what I mean by that. I'm going in a clockwise direction, 60 degrees. That would be coterminal with 300, but I have to go in the opposite direction. And that's what's so nice about having polar graph paper. It's really easy to go in the opposite direction, 3 units, all right? So 3 units, opposite direction. Let me see if I can do that. Whoops, let's get red ink out again. All right. So I'm just, one point at a time, graphing them out. So far, any points that graph 1, 2, 3, 4. Again, you may have to review this. I'm not sure, but I guess we could do some other points, right? So let's just talk about this, and I'm going to get a feel for it. It says you should note that -2 minus pi over 2 is the same thing as 2 pi over 2. Let me see if that's true. All right. So what are they saying? Again, I'm getting a feel for this. So minus pi over 2. Well, that's the point we just did before. Remember that? They said that the same thing as 90 degrees, 2 units. Certainly makes sense. So what you start to realize is that there's an infinite variety of writing these points down. I mean, there's an infinite number of coterminals. You got these opposite directions and all that stuff to worry about now. All right. So again, I want to point out, not that I want to do every single detail of what we're saying over here. I hope you get a feel for graphing. Give me one second. My pencil is whacked up here. I think you have a feel for plotting points. All right. And the graph paper that we're giving you. All right. So let's go talk about relationships now. Again, we can plot more points if you need to. And I'd recommend if you have struggle with this, practice what we just gave you. And certainly there'll be more opportunities to do that later as well when you're starting to do the examples and the homework that's assigned for you. All right, I'm going to go back to page number 1. And I want to talk about the relationships that you were given in Math 120. All right, so the relationships you were given in Math 120, you were given the following relationships. All right, you were given that x squared, and go back to black ink. You were told that x squared plus y squared is equal to r squared. That actually goes back to Math 100. That's what's known as a Pythagorean relationship. What is it? It's an equation of a circle centered at the origin whose radius is r. Now we're going to let r be any number at all, including negative numbers and 0. What we do, we divide both sides by r squared, which may seem strange to you, but I'll write that down for you. And what would you get there? You get x over r squared plus y over r squared is equal to 1. Well, this is a Pythagorean identity. All right, and what I mean by that, no, that's what you did in Math 120. The definition of x over r is cosine of theta in standard position squared, and y over r is a definition of sine of theta squared, and that equals 1. Pythagorean identity. So, let me write this on the side for you, and I'll write down one thing at a time. So we know that x squared plus y squared is equal to r squared. This is really important. The other thing we know from Math 120, we know that the sine of theta is equal to y over r, and we know the cosine of theta is equal to x over r. So nothing new here. I'm going to rewrite them a little bit differently, and they did this in Math 120 as well. I'm going to say y is equal to r times sine theta, and x is equal to r times cosine of theta. I'm also going to put a box on these two. All right. So I'm going to say, pretty simple facts you learned from Math 120, and they're going to be useful. We're going to keep reusing those over and over again. All right. So what I want to do is, talk about, what happens when we're given a problem to do and we're asked to do it. And certainly I'm not saying there's only one way to do a problem. What I'm saying is you have to be prepared for doing a problem like this over here. So what does it want me to do? It wants me to graph. I'll write this down for you. It wants me to graph r equals 2 sine theta times cosine theta. All right. Now I recognize that as being sine of 2 theta. So I recognize that. So I want to go through the techniques that you were taught in Math 120 to do this. All right, let's go to the next page. The polar graph paper, certainly you can use that. Certainly what I mean by that, you can, print this out as much time as you want, and you can use that graph paper if you like. All right. Now, again, let me write this down for you. This is the single worst way of doing the problem, but you were told to do this, by the way. And what were you told to do? If r is equal to 2 sine theta cosine theta, what some of your teachers said to do was come up with a table. And what table would you put down? Well, it would be r theta. And why is that? We write down r theta as a point, right? We plot those points. The problem with this, though, I'll be honest with you, it's incredibly tedious. And there's nothing wrong with that, but I find that to be very tedious to do. So looking at this over here, I want to point out what I did was I made a table of thetas and r over here. So I said, if theta is 0 degrees, r would be 0. What do? I plug it into the equation, and I go through this whole table over here. And then after doing that, and this is the single worst way to do it, it's really tedious, I'd have to plot the points. For example, the first point is 0, 0. Where would that be? Right there. And when I say that, I'm talking about r theta. That's 0. Whoops, sorry about that. And again, you may need to practice, plotting points. That's easy to plot. What's the next point going to be? Well, the next point is going to be, let's see, what's the r? About, I'm going to put down about, this is about, by the way. I'm looking at the second point, 0.87, that's about. And then the angle is going to be 30 degrees. What do? I locate 30 degrees and I move out. So something like this over here. All right. And you keep plotting point after point after point. And what do? You connect the dots. All right. So I'm going to claim, let me just see if there's anything else on that page. There's not. The next page, if you were to do that and plot all the points out, and by the way, what I mean by that, you're plotting one point at a time. All right. One point at a time. And you'd see these things wrap around and you'd eventually be able to connect them together. All right. So again, the wheels on the bus go round and round. You have to keep doing that over and over again, and you have to plot the points. What do you need to do? Plot points and connect the dots. All right. Let me point out where that says that. Connect the dots. Plot the points, connect the dots. What's the problem with that? Incredibly tedious. And there's no doubt about it, super, super tedious. However, when you took Math 120, they did that. All right. So next thing I'm going to talk about is tools. All right. Tools to graph. All right. So one tool I want to emphasize to you is that, and I'll outline this for you, that I don't mind using tools, by the way. Other teachers do. They say, oh, no, you should be able to do this by hand or memorize what these graphs look like. I'm not of that opinion, by the way. All right. So I'm going to say one tool that you were introduced in Math 120 was Wolfram Alpha, and that's the link to it. Remember, things that are in that magenta color are linkable in the notes. You just click on it, it'll bring you right over there. And I want to, we'll go look at the graphs over there, but you can get pretty sophisticated graphs, looking at, Wolfram Alpha. It's not a bad thing to do. Now, I'm also going to point out, those dinosaur calculators some people have, like the TI-89s, also can graph polars. All right, no problem at all. They can do it. I want to point out, I'm always pushing this application over here. It's available on OS 10. It's called Grapher. Grapher is a really nice package to graph polar coordinates out, or polar relationships. It's in the utilities folder if you have an OS 10 computer. If you have an iPad or even an iPod, you can have Wolfram Alpha on that. I like Wolfram Alpha, by the way. I'm not I don't know much about Windows PCs, but I think most people are probably using WinPlot. There's other software out like Desmos. You can also use Wolfram Alpha on that, Sage, yada, 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 all kinds of things. Also, if you're running Unix system, which most students are not, or Linux, they probably don't need to be told what to use. They're using what they want to use. All right, let's keep going. And I'm going to put this as an example of me using Grapher. All right, it's an elaborate graph. No, I couldn't do that by hand. The colors and all kinds of things like that. That'd be really tough for me to do, but Grapher is a really nice application. All right, let me just talk about the window from Wolfram Alpha, this one over here. And again, I'll be honest with you, I couldn't do it by hand. I really couldn't. There's no way. So what I do, I ask Wolfram Alpha to graph that. What does it do? It gives me a really nice picture. And what's the URL for Wolfram Alpha? Well, it's this one over here. This is the URL for it. Again, that's in the notes. It's clickable if you want to use it. It's super easy to use. All right. I would say as a default, Wolfram Alpha is probably the best application you could use as the simplest, easiest application. The problem with Wolfram Alpha, I want to be honest with you, is they're going to keep trying to sell you something. And there's always kind of like ads on it, and they want to sell you something. And sometimes they're going to say, oh, no, we're not going to do that for you unless you pay for our software. It does happen. All right. Be aware of that. You can always close it down and restart it if it's not letting you do something. Okay. So I'm going to talk about another way of doing it. And the other way of doing it is converting it. All right. So whenever it's like when someone's speaking a foreign language to me and I understand a little bit of what they're saying, I generally have to convert it back to English because it's the only language I really do know. So I'm looking at the polar, as I'm saying, polar forms, it's kind of unfamiliar to me. So another thing they told you to do in Math 100 is definitely know, and I'll write this down for you. You should definitely know that x squared plus y squared is equal to r squared. That's one thing you definitely should know. And the other fact that you should know is that y is going to be r times sine theta, and x is going to be r times cosine theta. So remember, I put these in the boxes in the beginning. I'm saying these are things you should know. So what am I confronted with over here? And I'll be honest with you, if I had to graph this without doing what I'm doing now, I'd have a tough time with it. Like if you're going to do tables in this one over here, which is what your teachers told you to do in Math 120, r theta, you'd pick thetas. Like for example, maybe you pick theta to be 0. What would you get? You get the number 4, so forth and so on. I mean, you could keep doing this, but the problem with this is incredibly tedious. So what I want to do is I want to say it's foreign to me, and I don't want to put tables down. So what I'm going to do is I'm going to take a look at the equation, and this is r equals 4, 1 plus sine theta. All right, this is just to review what you did in Math 120, by the way. Now, Math 120, they'd say convert it to a Cartesian equation. Well, first thing I would do is multiply both sides by the LCD. And if I did that, I would get r plus r sine theta is equal to 4. All right, that was pretty simple to do. Now, do you recognize r sine theta? Well, if you don't, go over here. What's r sine theta? It's y. So I'm going to write that down for you. So what do you get? R plus y equals 4. I got a problem now. It's mixing things. It's mixing the polar universe with the Cartesian, and I don't want that to happen. So what I'm going to do is I'm going to get r alone on one side, and I'm going to say 4 minus y. All right. Hope I didn't go too fast with that. What are you going to do now? Well, I'm looking at these three things over here, and I'm saying they're really important. I'm going to try to get r squared in the problem. How would I do that? I'd square both sides. Let me put that down for you. Now, what's r squared? Well, it's x squared plus y squared. And what's 4 minus y squared? That would be 16 minus 8y plus y squared. Right now, everything is gone that was from the polar system. I'm completely in a Cartesian now. I'm going to subtract y squared from both sides. All right, let me go through this one step at a time. 8y is equal to 16 minus x squared. And I'm going to divide both sides by 8 now. And what do you get? Y is equal to 16 minus x squared over 8. So someone says, I don't think that helped me at all. If that didn't help you, you're not familiar with the Cartesian system. This is super simple. What is this thing over here? It's a parabola that opens downward like that. Let me graph it out for you. Really simple. It's like a Math 100 question. This is x and y. By the way, the polar plane sits on top of that. If you want to use polar graph paper, you can. It's going to give you the identical graph. What are the x-intercepts? Plus or minus 4. What's the y-intercept? Well, if x is 0, that would be 16/8, which is 2. I'll put that down for you. And that's going to be 2 over here. And what does the parabola look like? This over here. Let me write down the x-intercepts for you. The x-intercepts are going to be minus 4 comma 0. The other x-intercept is 4, 0. The y-intercept, what's that going to be? 0, 2. What's the vertex? 0, 2. Axis symmetry, if I want to put that down, that's going to be x equals 0. All right, a lot of different things over there. So I graphed it. And how did I graph it? By converting to the Cartesian plane. Right, there's a problem with this though. Someone can say, I don't know what the problem is. Well, here's the deal. My goal is to get you to do this. Graph this using Wolfram Alpha or any graphing software you want to use software, and graph this using software as well. You will see they're identical in nature. They both look identical. There's no difference between the two. All right. So I'm going to say, not bad if I could do that. Unfortunately, sometimes you can't do that. Or if you do it, you don't recognize the Cartesian system. It's not recognizable. All right. By the way, they give you a picture over here of that picture I just gave you. And these things going forever in that direction. And that's the parabola. What is it being graphed on? Polar paper, which sits on top of the Cartesian paper. All right. So let's talk about derivatives now. All right. We'll get to calculus. All right. So remember, what x is. X equals, let me write this down. X is a function of theta. All right. It's a function of theta. All right. What's that function going to be? Let me write down x. Let me get this erased here. So x is a function of theta. All right. I'm sorry. X is a function of theta. Maybe I should put this down. I'm sorry. I made a mistake here. So x is a function of theta. I'm going to put this over here. And I'm sorry about that. I should have said that. R is also a function of theta. Now, x is a function of theta. R is a function of theta. What's x? X is equal to r. It's right over here. Cosine theta. So what do you get over there? F of theta times cosine theta. Now, y is also a function of theta. Well, what's the r? It's f of theta times sine of theta. By the way, we're not asking to memorize. All right. So what do we know about this? And I'll outline what we know. We know the relationship that x equals r times cosine of theta. We know that y is equal to r sine theta. What did I do? I went on to say that r was a function of theta. So when I saw the r, I just put down the r for that. All right. Cosine of theta, well, that's pretty simple. Sine of theta, pretty simple. All I'm saying now is x is related to theta. That's all we're saying. All right. So this is important. Now, granted, someone's going to say, is that all I need to remember? For the most part, it is. Now, of course, I don't want to remember what follows it, but I want to write this down for you. All right. I want to write down each step separately. So I'm going to write down x prime theta, which is dx d theta. All right, let me write that down for you. So I'm looking at this over here. So what would you get? Well, I'm going to put down f of theta. I'm using the product rule. Times root of cosine theta. Well, that's going to be sine theta, but it's the opposite, right? Plus f prime of theta. And you know the product rule, by the way, cosine of theta. All right, I'm going to put down y prime theta. And what's that going to be? dy d theta. Boy, it's going to be tough. Product rule, right? So what do we get over here? F of theta times the derivative of sine, which is cosine of theta, plus, using the product rule, f prime of theta times the sine of theta. All right. I want to go back over here and point out this stuff is written down for you right over here. Now, what do I want to do? I want to do dy dx. What's that going to be equal to? dy d theta over dx d theta. Or if you prefer, you could write down x prime theta. I'm sorry. Y prime theta over x prime theta. Let's write this down. What's y prime? Minus f. And again, I'm not asking you to memorize this. We're deriving it. Sine theta plus f prime times cosine theta. Now what goes on bottom? F of theta times cosine theta. Make sure I'm doing this right. Oh, you know what? I'm doing it backwards. I'm sorry. I'm looking at something and I got it backwards. I got to pay attention here. Gotta erase this over here. Sorry about that. Whoops. It's tough though. I'm not saying it's easy. What's y prime? Sorry about that. It's f theta cosine theta. I wasn't reading my own work. F prime theta times sine theta. Don't worry, we'll check on the key. And what goes on bottom? Minus f of theta times sine of theta plus f prime of theta times cosine of theta. All right, let me just make sure you know this is written down for you. And what do I see over here? And again, I'll check it for you. F theta cosine theta plus f prime theta sine theta. Top's right. Minus f theta times sine theta plus f prime theta cosine theta. Looking good. All right. So I'm going to say not bad. All right. Not bad. So over here, you should note that f prime of theta is df d theta. Yeah, that's not bad. All right. So let's see if we can do something here. So they want me to do this in two ways. You know, I'm going to do this over here. I'm going to put this, I don't know what two ways they want me to do this in, but I'll write down, given this thing, find dy dx in two different ways. Well, I think the easiest thing for me to do is just convert it to the my Cartesian form. So this would be R cosine theta minus R sine theta. Make sure I did that right, equals 1. What's R cosine theta? That's X, right? Minus Y is equal to 1. And so Y would equal X minus 1. So dy dx is equal to 1. Well, that wasn't bad. All right, so this is new to me. I think I did this pretty good. All right, let's go to the next page. Maybe not. Maybe we'll do two different ways. So let's see if we can do this. And I don't know, dy dx. Let me write this down. Well, question is, let's write this down. I want to do the derivative here, right? Dy dx. So remember, R is a function of theta. And what is that function? Kind of looking at it. So I think I can write this down. So dy dx equals, it can get tough. Well, let's write this f of theta down now, okay? So I'm using the formula over here. And that's going to be f of theta, which is 1 over cosine theta minus sine theta times cosine theta. I'm just copying the formula. Now I got to do f prime. Boy, it's going to be a lot of work. And that's going to be what? Cosine theta minus sine theta squared. Then I'd get the bottom to the top times root of the top, which is 0, minus the top times the derivative of the bottom, which would be minus sine theta minus cosine theta. Boy, this is going to be a lot of work. All right, I think we can do it though. And then what's going to be times sine theta. Let's look at my formula. And this doesn't look like it's going to stop. Minus f of theta, that's minus 1 over cosine theta minus sine theta. I hope you can appreciate the utility of what I did over there. Boy, that was easy, wasn't it? Times sine theta. Plus f prime of theta. Well, I just did that, so I'm going to just do it again, but I'll write it down for it because I don't want to do that really again. What does that top simplify to? Sine theta plus cosine theta. All right. And then don't forget the time cosine theta now. Boy, this looks like it's going to be a lot of work. Now, let me go back over the advertisement. That was super easy what I did over there, wasn't it? Yeah, super easy. Let's write this down. Dy dx. I am going to multiply the top and bottom equation by cosine theta minus sine theta squared. So what do I get? Let's write this down. You would get cosine theta minus sine theta times cosine theta plus, and what are you going to get over there? Well, you're going to get sine theta cosine, whoops, sorry about that. Cosine theta times sine theta. Boy, is this a lot of work. Minus cosine theta minus sine theta, sine theta. Oh, this is not going to end, is it? Plus sine theta plus cosine theta times cosine theta. This doesn't seem like it's ever going to end. Let's keep going. And what do you get over there? Cosine squared theta minus sine theta cosine theta. Whoops, let's keep going. Plus sine squared theta plus sine theta cosine theta. Let's do the bottom. Minus cosine theta sine theta plus sine squared theta plus sine theta cosine theta plus cosine squared theta. Wow, I don't know if this is going to end. Wow, it ends. What do we get? This disappears. Cosine squared plus sine squared is 1. This disappears. Sine squared plus cosine squared is 1. What do you get? 1. Getting the same answer? Of course we are. Let's take home message. Use your head. All right, let's go to the next page, see how bad it is. Their work. And they go through all the work for me. All the work, all things. All right, so where are we now? We're going to be doing the examples next. But here's the deal. What are we doing? I guess we're doing the same thing we did in Math 120, polar coordinates. But now we got an additional problem. We have some calculus to throw on top of it. All right, we'll get the examples later. Thank you.